Hello, welcome to the Synthetic Division podcast. So we're going to learn another way to divide, and you might have thought, well, why are we learning two ways? Well, each way has its benefits and has its issues, right? So that's why we have to learn two ways. This way, synthetic division, if you don't know long division, it won't make any sense, right? So that's why we have to learn long division first. Also, you'll see on the next slide, I'm going to go over some other reasons why long division is important. But you want to learn synthetic division as well. All right, so let's convert to synthetic division. The name synthetic means we're not exactly dividing, but we're doing something that allows us to actually divide in a different way. So we're not truly dividing, but the steps that we're taking, in the end, we get the quotient. So for synthetic division, we use only the coefficients of each term, and we change our divisor into the actual 0. So we change x plus 1 into x equals negative 1. Right? We just set it equal to 0 and solve for x. Instead of multiply, subtract, we now multiply, add. The benefits of using synthetic division, there's less writing and it's faster. And that's really important when we are solving using division, because you may have to test several values to figure out which are your zeros. And so if you have to test several values, you want something that's a little quicker, and you don't have to write quite as much. So that's one of the benefits, two of the benefits of synthetic division. But the problem with synthetic division, it only works when your divisor is x plus or minus a constant. So if we go back here to some of the division problems that we did, so for instance here on the whiteboard practice, all right, it wouldn't work for 2a plus 5, dividing by 2a plus 5, because that's not a plus or minus a constant. It definitely doesn't work for x squared plus x plus 1. We couldn't use synthetic division for those. But we could have used synthetic division for number 2 there, where we're dividing by x minus 3. Okay? So synthetic division doesn't work all the time, right? So we can't always rely on that. So the benefits of using long division, it works for any problem. You can divide any polynomial function by a divisor and find the quotient. The problem with long division is it takes a little bit more time than synthetic division. So as we move towards solving with division, we're going to want to learn a way that we can do it just a little bit faster. Okay, so here's our first problem. 3x cubed minus x squared minus 3x plus 1. And we're going to divide by x plus 1. I have the steps there underneath, and they're also in your notes. And I have given away pretty much every one of my copies of notes. So you look around at on your notes there and see whether which problems are in your notes, because I no longer quite remember which ones I chose, and I don't have the notes in front of me, right? And I know that it's only at the bottom of the notes, the bottom of the last page. So I believe I think I left 3 problems for synthetic division. So just be looking to see which 3 it was. All right, so I have the steps there. Our first thing is we're going to write the coefficients of the terms only. If we have anybody missing, we have to represent them with a 0. So remember when we did long division and we didn't have an x to the 4th, we had to represent it with a 0. Here we have everybody. We have the cube, we have the x squared, we have the x, and we have the constant term. So we're only going to write the coefficients. So that saves us a little time. So instead of writing 3x cubed, I'm just going to write a 3. Instead of negative x squared, I'm going to write a negative 1. Instead of negative 3x, I'm going to write a negative 3. And instead of, 1 is just going to be 1. All right, our divisor is x plus 1, so I set that equal to 0 and solve for x. So x is negative 1. So negative 1 goes outside the house. So this little box I drew here, kind of this upside down box, kind of looks like an upside down division symbol to me. Excuse me. Will help us keep everything organized. So we'll always use that when we're using synthetic division. All right, so I changed the factor to the 0, negative 1. Right? And my first step is I'm going to bring down the first term. exactly as it is. This 3 just comes right down and I put it here. This is where we're going to multiply from. So we're going to use the values below the box there to multiply. And any values in a column, we're going to add. Those are the only 2 operations we have here, multiply and add, multiply and add. Okay? And it's because we only have 2 different operations, multiply and add, we don't bother to write any symbols. Right? We just remember them. Okay? Because that's, if you're below the line there, you're multiplying. And if you're in a column, you're adding. Okay? So that's kind of easy to remember. All right, so I multiply, and I'm multiplying it times my 0 there, the value of x in my divisor. So 3 times -1 is -3. Okay, so they're in the column. All right, so I add those. Oh, I was trying, by the way, to be color-coded so that you could follow the colors with the steps. And I messed up my color because multiply right in the next column is in black. So 3 times -1 is -3. I write it in the next column, and so there the step now matches the color. And now we add the column. So -1 plus -3 is a -4. And now we just repeat. We just keep doing the same thing. So now I work with the -4, and I multiply it by the -1. You're always multiplying it to your 0 here, the number in your divisor. So -4 times -1 is a +4. It's in the column. We add. -3 plus 4 is 1. 1 times -1 is a -1. I put it over here in the next column, and then I add, and I get 0. Okay? So these numbers mean something. The last number is always a remainder. The next number is the constant term. The next is the x, and then x squared, and it always goes in that order. So my quotient here is x squared plus x, oh, excuse me. Well, it helps if you put I forgot to write the coefficient in front of it. Sorry. 3x squared minus 4x plus 1. Okay? And because our remainder is 0, x plus 1 is a factor. X equals -1 is a solution, because the remainder was 0. Now, I think we've seen a problem just like this before. Let's go back a few slides. And for this nice long problem, for this one, I think it's maybe right here. Look, 3x cubed minus x squared minus 3x plus 1 divided by x plus 1. Right, so there we use long division, and we got 3x squared minus 4x plus 1. Here we use synthetic division. Well, pretty soon we use synthetic division. A few more slides. I think one more. Here we use synthetic division. So you can see, oops, and not too many. And you can see how much less writing there was. Right? So when we have the opportunity to use synthetic division, particularly when we're solving polynomial functions, and we can't use perhaps pulling out a greatest common factor or factor by grouping, and we want to check different answers to see if there are a solution, this will save us some time. All right? So I'm going to go for the rest of this podcast. I'm just going to go over synthetic division and do some problems with you. Okay? All right, so, and it's always these same steps. All right, so here's the next one. This one actually, I'm going to do one step per slide, and this one's actually all filled in. So you'll just kind of follow along with me. This one is not in your notes. So here we wanted to, we're going to be working with 5x to the fourth minus 4x squared plus x plus 6. Now that particular equation does not have a cubed term, and it doesn't, I think that's the only one that's missing. It doesn't have a cubed term, excuse me. So we represent that cubed term with a 0, so 0x cubed. So since the numerator does not contain all the powers of x, you must include a 0 for the x cubed. Just like we had to do, just like we did with the long division, we had I think it's 0x squared, right? So if we're missing somebody, we need a placeholder. We can't just leave them out. We write the constant a of the divisor, right, to the left outside our little box here. In other words, you set x minus 3, your divisor, equal to 0, and solve for x. So since the divisor is x minus 3, 3 is what we're going to be working with. Right? And then we write our equation with just the coefficients. We leave off all the variables. Right? So it's real important that we have all of our spaces represented. Right? And that's why we have to include the 0 for the x cubed. We can't leave them out. Otherwise, our equation will be all messed up when we try to divide, because we'll be missing a whole place. All right, so now just watch along. All right, so my first step, we bring down the 5. All right, so the first term, you just bring it down, and that starts the process. And our next step, we're going to multiply. And you're always multiplying the number below the line with the number you're dividing by. So we have 5 times 3, and that gives us 15. And then we add. 0 plus 15 is going to give us 15. And we add the column. And now we multiply. 3 times 15 is going to give us 45. So we write it in the next place. So notice we just keep writing it underneath the next term. So now we add. Negative 4 plus 45 is going to give us 41. Okay? So we're multiplying. I like to think of it as if you're below the line, you're multiplying it. In my slideshow here, we have multiplied the diagonals because they're diagonal to one another, and add the columns. I say add the columns too, but if it helps you, you can also think of it as multiply when you're below the line, right? And then we just keep repeating. All right, so negative 4 plus 45 was 41. And then we multiply 41 times 3. 41 times 3 is 123. And then we add. 123 plus 1 is 124. And then we multiply. 124 times 3 is 372. And then we add. So the very last number is always the remainder. Here our remainder is not 0, which means that x minus 3 is not a solution. Because the remainder is not 0. Right? And then, of course, the next to the remainder is the constant, and x squared. Now we have 5 terms here, so the next one is x cubed. If we had 6 terms, the next one would be x to the 4th, and so forth. So it's interesting to compare the long division process to the synthetic division process. For example, here we have a long division problem and the synthetic division problem right next to it on the right. Notice the same pattern of coefficients is used in the long division appears in the synthetic division process. So now look at those coefficients that are in red, right? The 3x cubed. Notice that is, and notice we have to subtract, so it's a negative 3x cubed. So notice we have a negative 3 under the 4. So you see the 4 and the negative 3 on the long division, 4 and negative 3 on the synthetic division. Okay? And then if you look to one line below that, you see we're adding 0 and negative 3 on the long division. And now you look to the synthetic division on the right, 0 and negative 3. I don't know, I should probably here, maybe, oops, I don't want that, I want that. Maybe I'll grab like an oval or something and I can ring them, right? So here we have it on the long. There it is in the synthetic. Actually, probably make my oval a teeny bit bigger. Here it is on the long. There it is in the synthetic. We go down one more row, 5 and 9. 5 and 9. And then 6 and 42, or excuse me, negative 6 and negative 42, negative 6 and negative 42. Right? So by making that term, our divisor, the opposite, by making it the actual solution, and doing the opposite, multiplying instead of dividing, you see we end up in a new way being able to divide. That's why it's called synthetic division, because we're not actually doing division, we're using multiplication to get the same result. So here we do have a remainder, right, negative 48, so it's not a factor, right, and notice we have that same remainder here. And then these coefficients, 1x cubed, 1x squared, negative 3x, and 14. And it's the same ones you see over here, right? My magic oval. All right, so you're doing the same operations, but in a slightly different way. And in a faster way, which is nice when you have to test maybe 3 or 4 different numbers. All right, so let's take a look at this one. I'm going to try to keep it color-coded the best I can with my steps below. I have to remember to change my color pen. All right, so I'm going to write the coefficients of the term and represent missing values with a 0. All right, I got a cube, I got a square, I got an x, I got a constant, I'm all good. All right, so 1, negative 1, be careful, if there's a subtraction sign, it's negative. 4, negative 4. Okay, so those are the coefficients. And then if we have x minus 1 equal to 0, x is 1, so that's going to be my divisor. And then I bring down the first term. So I bring down the 1, the first term in the sequence there, and that starts the process. So now I need to multiply. 1 times 1, I'm always multiplying it by that number, our divisor. 1 times 1 is 1. I write it in the next column. I add the columns. Right? So negative 1 plus 1 is 0. And then I just repeat. All right? So then I'll try to even color code on the repeat. So now we go to the multiply, right in the next column, right? So multiply, right in the next column. So 0 times 1, matching my step here, is my color black, right? Because I'm doing step 4 again. So the steps that repeat all the time are 4 and 5. Multiply, add, multiply, add. All right, and then we add the terms in the column. 4 plus 0 is 4. And then we multiply. 4 times 1 is 4. And then we add. Negative 4 plus 4 is 0. All right, this one is our remainder. It's no remainder, so this is a factor of x cubed minus x squared plus 4x minus 4. This is our constant. This is the x, and this is the x squared. All right, so let's take a look at this. We have x squared, no point in writing 0x, plus 4 is our other factor. So that means that if we were to factor our equation here, our two factors would be x squared plus 4 and x minus 1. All right, so those are our two factors. Now, if we were solving and wanted the solutions, well, we already know one of them is x equals 1. We could solve the other one. Now, the other factor. Now, this is not a difference of squares, so I won't be factoring it using that technique. I have to use square roots, because what I have is a sum of squares. X squared plus 4 equals 0. And we're going to see that these are not x-intercepts. If I subtract 4 from both sides, I have x squared equals negative 4. If we take the square root of that, don't forget plus or minus over here, I have x equals plus or minus, the square root of negative 4 is 2i. All right, so I have 3 solutions, 1, 2i, and negative 2i. Those are my 3 solutions. I have only one x-intercept, however. Right? The only one is the 1. So I'm only going to cross the x-axis one time. All right, so let's take a look at this one, and then we're going to factor and solve. All right, and so I have the steps listed above. This time I probably won't worry about being color-coded. All right, I think I've done it enough times in the color coding. All right, and I'll go through the steps each time anyway. So number 1, in red there, we're going to write the coefficients of our terms. All right, so maybe I'll still write that in red. All right, so we've got a cube, 3. We've got a square, negative 16. We've got an x, 3. I've got a constant, 10. Right? And then we change the sign of the divisor. So my divisor is x minus 5. Set that equal to 0. So x equals 5. 5 goes outside the house. All right, and then we bring down our first term. And then we multiply. So 3 times 15 is going to be 15. We add, right? Negative 16 plus 15 is a negative 1. We multiply. Negative 1 times 5 is a negative 5. We add. 3 plus negative 5 is negative 2. We multiply. Negative 2 times 5 is a negative 10. And then we add. Negative 10 plus negative 10 is 0. Right? This is our remainder, constant, x squared. All right? So that particular equation is x squared minus x minus 2. Right? We have a remainder of 0, so that is a factor. So this is one factor and one solution. So these are our solutions here. X equals 5. Let's find the other. We can use factor by grouping for quadratics. 1 times negative 2 is negative 2. Two numbers that multiply to give us negative 2, but add to give us our b term of negative 1, negative 2, and 1. So we have x squared minus 2x plus x minus 2. The first two are a group, the second two are a group. We'll factor out the x, we have an x minus 2. Factor out the 1, we have an x minus 2. And so factored, we have x plus 1, x minus 2. And that means, oh, I should have set this equal to 0, I'm sorry. And that means our other two solutions are x plus 1 equals 0. So x is negative 1, and x minus 2 equals 0. X equals 2. And those are all our solutions. We have 3 solutions because we're cubic, right? And in this case, we have 3 x-intercepts because they're real. Actually, I'm going to check and see how many slides I have left. I only have 1 slide left. Right? So I'm going to save this 1 slide for tomorrow, just to kind of review it before you do a whiteboard practice. And that's the end of, not the end of my podcast. I have one other thing for you. So we'll do this problem in class. We'll do these problems in class. And I have my closing for you. And that's not it. Did I write it down? Dun, dun, no. All right, I'm going to write it down right now. I'll go along. I know what it was going to be anyway. Closing. Compare and contrast long and synthetic division. And don't just write down exactly what I said. You can use my word, use what I put in my notes, but maybe put a little bit into your words, All right, so compare and contrast long and synthetic division. Right? Tell me how they're the same, how they're different. Okay? Kind of like I did earlier in this podcast. Right? And that is your closing. You can stick it under Thursday or Friday's closing, giving you 2 closings for this week. Now this is the end of my podcast, and you can turn this in on Monday. You can turn the bell we're closing in on Monday, and then your notes. I don't remember if this is probably one problem in your notes. We'll do this one in class on Monday, and then we'll do this classwork, and then we're going to be using long and synthetic division, mostly synthetic, to solve polynomial functions where we're not going to be able to necessarily use factor by grouping. All right, so that's the end of my podcast. Have a good weekend. Bye.